Okay, so welcome back. Now, we're going to do some examples. So the first example we're going to do is regarding dropping an object from a particular height and then answering some questions based on the position function given. So it says a ball is dropped from a height of 64 feet. Its height above ground in feet t seconds later is given by the function s of t equals negative 16t squared plus 64. So there's the information that I just read. So that's what I wrote down. So the initial height, 64 feet, and the position function is given by this formula. Notice that the 64 here matches here. This is actually the initial height for the position function. It always gives you the initial height here. Okay? Now, what we're going to do is we want to find, so the first question they ask is, what is the instantaneous velocity of the ball right when it hits the ground? So in order to do that, well, first of all, we need, since they're asking about velocity, we need a velocity function. So let's get the velocity function by taking the derivative of the position function, which is then going to give us the function, what? Well, we're going to apply the derivative rules, right? So this is going to give us negative 32t. Now, well, we want to know what the instantaneous velocity is, that's this, when it hits the ground. Well, what's the height of the ball when it hits the ground? 0. Okay, well, we're going to need to approximate this. Okay? So, we have to determine how long the ball was in the air. How long was the ball in the air? In order to do that, we have to use the position function because we want to set this position function, because this represents the height of the ball after t seconds, right? So we need to find t to solve this one. Well, how are we going to solve t? Well, we're going to have to use the position function because what they tell us is that the ball hits the ground, so the height of the ball is going to be equal to 0. So what we need to do is we need to solve for t here. And then once we solve for t here, we can plug t into this function, and we have it. So let's do that. So, we solve for t here. That's going to give us what? Negative 16t squared is equal to negative 64. And then we're going to divide both sides by negative 16, which is going to give us t squared is equal to 4, which then if we take the square root of both sides, we're going to get t is equal to the plus or minus. Don't forget, when you're taking the square root of both sides, you got to have plus or minus. The square root of 4, which equals plus or minus 2. Now, obviously from the context of the problem, we're not interested in negative time, right? So, t equals 2. Okay? So now what we're going to do is we're going to plug in 2 into the velocity function, and we're going to get negative 32 times 2, which equals negative 64. And what's the units? Now again, if they give you context and they give you units, you need to use the units. I will take points off if you don't use units when you should. So I would say the velocity at 2 seconds, the instantaneous velocity 2 seconds after the ball was dropped. In other words, the ball hit the ground 2 seconds after it was dropped. But, so the velocity of the ball when the ball hit the ground was, it was going at negative 64 feet per second. Now, where does the negative sign come in? Well, the negative sign means that it was heading towards the Earth, right? Because the height was getting smaller and smaller and smaller. Okay? Now, what's the average velocity of the ball during its fall? Well, that's easy, right? The average velocity would be the velocity, initial velocity, and the final velocity. So the average velocity is equal to what? The final velocity minus the initial velocity over the time period, right? So this is going to be equal to what? Negative 64 minus 0, because it was not moving at t equals 0, over 2, right? So this is going to be negative what? Negative 32 feet per second. So not a very good average, right? So big difference. But again, this is an average, so it's taking the average over the whole 2 seconds. Okay? Okay, that's it. Have a great day.